My dear friends, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about subject signals and systems, and today's topic is we are going to discuss properties of ROC and problems on Laplace transform. Very important topic. And before going to discuss our topic today, all of you subscribe, share the channel. This channel is very helpful to you. Let's start our session. Properties of ROC. First we discuss properties of ROC. Then we can do some problems on Laplace transform. So today's topic properties of ROC. Properties of ROC. So we know ROC means region of convergence. Region of convergence. So we discuss properties one by one. Like point wise we can see. So the first point is the ROC of a signal x of t, ROC of a signal x of t consists of strips parallel to the imaginary axis, parallel to the imaginary or j omega axis. This is the first point. ROC consists of strips parallel to imaginary axis or j omega axis. This is the first point. In S-plane axis, in S-plane. Generally we plot ROC in S-plane, right? So in S-plane we have real axis and imaginary axis. Second point, the ROC does not contain any pole. The ROC does not contain any pole. Okay. And the third point, if x of t is finite duration, if the signal x of t is finite duration, it is like finite duration and absolutely integrable, then ROC is entire S-plane. So how is the ROC of this kind of signal? Finite duration and absolutely integrable. Then ROC is entire S-plane. So this is the third point. And fourth point, if x of t is right-sided signal, then ROC is of the form, it is like, or of the form ROC is greater than, it is a right-sided signal, so ROC is greater than sigma maximum. What is sigma maximum is here, where sigma maximum is the maximum, it is the maximum real maximum real pole or real value maximum real value of pole or poles. That is the sigma maximum real part of any of the pole. Maximum real part or maximum real value of poles, any pole. Next, fifth one, left sided signal. If x of t is left sided signal, it is a left sided signal, then ROC is of the form, it is like or of the form. So left sided signal, that is why ROC is less than sigma minimum. What is sigma minimum here? Where sigma minimum is the minimum real value, minimum real pole or poles of x of s, real pole of or poles of x of s. Okay. Now the sixth one, if x of t is two-sided signal, double-sided or two-sided signal. If x of t is two-sided signal, then ROC is sigma 1 less than ROC or real part of s is less than sigma 2. So ROC will be like sigma 1 to sigma 2. Okay. So these are the properties of ROC in case of Laplace transform. If x of t, how is the ROC? That is the first point. ROC consists of strips or parallel lines, strips parallel to j omega axis in S-plane. And the second thing, the ROC does not contain any pole. Third point, if x of t is finite duration and absolutely integrable, then ROC is entire S-plane. And fourth one, if x of t is a right-sided signal, the ROC also right-sided. And like sigma maximum greater than, sigma maximum is maximum real pole of x of s. If x of t is left-sided signal, ROC also left side, less than sigma minimum. Sigma minimum means minimum real value or real pole of x of s. Double-sided signal, then ROC is like sigma 1 to sigma 2. These are the properties. Let's have another problem. Laplace transform of del of t. Unit impulse function. What is the Laplace transform of del of t? So we know Laplace transform formula. Laplace transform of x of t is equal to x of s is equal to integral minus infinite plus infinite x of t e power minus st dt. So here given x of t is the del of t. So in the place of x of t, we take del of t e to the power minus st dt. And here we have product like del of t into x of t. This product will become del of t into x of 0, because del of t is available only at t is equal to 0. So signal get multiplied only at t is equal to 0. That is the reason integral minus infinite plus infinite, here del of t into e to the power minus 0 dt. So which will be integral minus infinite plus infinite del of t dt. So this integration indicates area under impulse. Area under impulse. And what about ROC here? So here e power s into 0, e power 0. So for all values of s, for all values of S or entire S plane. So the ROC is here for all values of S or entire S plane. So here del of t dt integration minus infinite plus infinite. It is a area under impulse which is equal to 1. So therefore the answer is 1 and ROC is entire S plane. This is the Laplace transform of del of t is equal to 1. Okay, and ROC of impulse is entire S plane. Next, another problem. Find Laplace transform of the signal e power minus at u of t plus e to the power minus bt u of minus t. What is the Laplace of this given signal? And ROC also. We want to determine ROC also. So already we know this e power minus at u of t Laplace. So Laplace transform of e power minus at u of t. How much? 1 by s plus a. And what about ROC here? ROC is real part of s is greater than minus a. So take it as 1. Already we know this. Already we completed. And the second one, Laplace transform of e power minus bt u of minus t. Right? E power minus bt u of minus t. Its Laplace transform is minus 1 by s plus b. So here minus we get, right? Minus 1 by s plus b. And ROC is real part of s is less than minus b. Real part of s is less than minus b. So when the Laplace transform converges, that depends upon these two ROCs. Okay, so the first ROC is greater than minus a and the second ROC is less than minus b. For example, here a and b are the constants, like real numbers. Let's take, for example, a is equal to 3 and b is equal to 4, for example. So greater than minus 3, this is the minus 3 greater than, and b is equal to 4 means minus 4 less than minus 4. So this is the minus 4 less than. So there are no common ROC here. Therefore, Laplace transform not exist in this case. A value 3, b value 4. For example, you take reversely, b is equal to 4, a is equal to 3, for example. Check in this way. So b value, how much? 4, right? So real part of s is less than minus 4. So this is the minus 4 less than, minus 4 less than means left side, and minus 3 greater than means right side. Okay, so ROC not common here again. So Laplace transform not converges. Laplace transform not converges. So b value left sided. So b, for example, b is here, a is here, then we have common ROC from a to b. Common ROC from a to b because less than b and greater than a. So this is the common ROC a to b. Right or not? So how should be the a value and b value? That we have to decide. How to be a value and b value so that Laplace transform converges. So that Laplace transform converges. Just discuss again. So less than minus b. For example, this is the b. Less than minus b means left side. Greater than minus a. Greater than minus a. Suppose this is minus b and this is minus a. Greater than minus a. So b value must be like 2. A value must be like 3. Right or not? So a value must be smaller than b value. Then we have common ROC, so that we get the answer, Laplace transform answer, or Laplace transform converges. So this is the way, right or not? So final ROC is a to b minus a to minus b, right? So the final ROC is minus a less than real part of s less than minus b. And here, how is the relation between a and b? How is the relation between a and b? So to get the Laplace transform converges, how should be a and b? Here we have discussed a value and b value. So minus b means minus 2 here, minus 3 here. So greater than minus 3, less than minus 2. So by comparing these two, we can say a value is with negative, a value is smaller than b with minus 3 minus 2. So minus 3 is smaller than minus 2. So generally in real positive sense, in positive values, with positive values, a is greater than b. A is greater than b. So a value like 3, b value is 2 or 1. Now minus a will become minus 3, minus b will become minus 2, and we have real part of s is greater than minus a means greater than minus 3. Real part of s is less than minus b means less than minus 2. Then we have minus a to minus b. This will become final ROC. So that is a way of thinking ROC. After ROC, we can write final answer. X of s is equal to 1 by s plus a plus 1 by, here plus into minus 1 by s plus b. So do LCM here, s plus b minus of s plus a divided by s plus a into s plus b, plus a into s plus b, s plus a into s plus b. So here we can do simplification, s get cancelled, and b minus a by s plus a into s plus b. So this is the final answer, b minus a by s plus a into s plus b. Okay, right? So here e power minus at u of t, this is the right sided signal, and e power minus bt u of minus t, this is the left sided signal, right? Here we have right sided signal, left sided signal, then ROC is like minus a to minus b, like sigma 1 to sigma 2. This property we discussed in ROC properties. This point we discussed. This is the example related to that point. Thank you, students. Thank you very much.